If a real sequence series, positive series, is divergent, then whether or not the following series are convergent or divergent. The first series, I noticed that there is n squared at the bottom. So which means probably I'm going to have to loosen the inequality a little bit. Get rid of the 1. n from n1 to positive infinity. an over 1 plus n squared an. Get rid of the 1. Loosen it a little bit. Because the bottom becomes now smaller. The whole fraction becomes bigger. N equals 1 to infinity. an over n squared an. Alright, so that way, basically it's just 1 over n squared. Obviously convergent. So this is no problem, convergent. But number two, I say if depends. Depends if an is equal to, for example, 1 over n, right, what's going to happen? So I have infinite sum from 1 to positive. I have 1 over n over 1 plus 1 plus 1. Right, that is. So essentially that is just, so this is obviously a, perhaps take out the half. So this is a half times a harmonic series, of course, divergent. If that's the case, it's divergent. If I say if an is equal to equal to 1 every time n is equal to m squared. Right? In other words, every time when n is a perfect square number. Right? If n is otherwise not a perfect square, right, then we define it to be 1 over n squared. So that way, it still satisfies this condition, right? So in a series of this is still divergent. Right, so this bit series sum up to be divergent, but this bit will actually go to positive infinity. So the whole series still be divergent. However, if we substitute this into this series, right, an over, so that way, n 1 to infinity, an over 1 plus n times an is in fact equal to 2 parts. Right? First sum, when n is equal to m squared, right, in that case. So that way, an becomes 1. 1 over 1 plus n times 1. n equals m squared. Right? But m, there are many possibilities. For example, m can go from 1 to infinity. N could be equal to 1 square, 2 square, 3 square. Right? They're all possible. So this bit, second part, when n is not equal to m squared, right? I have 1 over n squared. In fact, I can just add a little bit more terms in here. Right? I can say that if I add when n equals m squared, I can, for example, n equals 3 square, 5 square, right? 1 over 5 square, 1 over 3 square. We become a little bigger. Make it a little bit bigger. Right? N goes from 1 to infinity. Just loosen it a little bit. Right? So that way, this series, of course, the main So get rid of the 1 here, right? Make it a little bit bigger. So of course, this series is obviously convergent, right? So is this series. So overall, it's still convergent, positive series, comparison test, right? So number 2 can either be divergent or convergent. It depends. Depends. Number 3, let's say if AN, let's say 2 possibilities. If AN is bounded, right? AN is bounded above, for example, right? N is bigger than 0. In that case, this infinite sum would be loosened again. Let's loosen it. 1 plus AN is bigger than or equal to. This time, let me replace AN at the bottom with M, right? So replaced with M, so the bottom becomes bigger. The whole thing becomes smaller, right? So AN over 1 plus M. M is fixed positive number. So given that AN is series is divergent, right? So this is obviously divergent. If AN is unbounded, meaning there is a subsequence, A sub N sub K. As K approaches infinity, this subsequence will approach positive infinity. That's what it means, unbounded, right? So which means I have this general term, subsequence general term. I have A sub N sub K over 1 plus A sub N sub K will approach, divide everything by A sub N sub K, right? 1 over A sub N sub K plus 1, right? Will approach 1, right? Because AN K approaches positive infinity, right? So which means my general term AN over 1 plus AN, there's no way for this general term to approach 0, right? So meaning it's impossible for the series to be convergent because that's a minimum requirement, is the general term has to approach 0, right? So it must be divergent, right? Under any case, right? Divergent. Number 4, right? I said number 4 also depends. If AN, let's say, is equal to N squared, what's going to happen? Right, so N squared, right, infinite, still divergent, right, still positive series. In that case, and I have infinite sum N from 1 to infinity AN over, so N squared over 1 plus N to the 4th, right? Of course, no larger than, get rid of the 1 down here, make it a little bit bigger. Right? N squared over N to the 4th equal to N from 1 to infinity 1 over N squared. Obviously convergent, right? In this case, if AN is equal to N, let's say, still infinite sum of N still divergent, right? But this time I have N goes from 1 to infinity of N over 1 plus N squared, right? But this is equal to N goes from 1 to infinity, divide everything by N, right? 1 over N plus N looks like it's going to diverge, because I'm going to loosen it a little bit, right? Make the denominator a little bit bigger, so the whole thing will become smaller. Make 1 over n a little bit bigger. Replace 1 over n with 1. Right? 1 over 1 plus n. Right, so this infinite sum, right? Obviously, harmonic series, right? Except I start from 1 over 2, 1 over 3, 1 over 4, right? But still, missing the first term of a harmonic series, 1 over 1, doesn't impact the divergence, right? Still divergent. So, also depends.